Hello, this is Kim Nelson. I'm going to continue a tutorial here for finishing out the detail surfacing on this cuff bangle. The only thing really to be done here, aside from the fact that I'm realizing I think the prongs are too small, is to do the final detail of sculpting out that top surface detail. So I don't really have a good copy of my original design left in the file, apparently, which surprises me because I am usually really good about hanging on to curves. So take a minute here and just go ahead and redraw it, the portion that I need, which isn't much. Couple of construction lines. I'm only interested in this to where it ends, and this to the current top and inside parameters. Also be useful to get the parameters surrounding the stones. And a cut line for the widest portion of this window or this bay. Which is approximately there. Extend by arc to point. It's not going to give me what I want. So actually, to get this outer curve, I'm going to also need the width. Here and here, essentially redrawing the whole segment. Okay, so having that now, set up a blend curve between here and here. Like so. Same thing for this outer line. Close enough. And blend curve here. Join that. And I believe that's everything I'm going to need. There. Not a bunch of effort after all. So all of that so I can draw this accurately. Reestablish center lines. High point, low point. And width. Okay. I don't want a sharp point here, even though my drawing has a fairly sharp point, and I can have a fairly sharp point. I don't want an entirely sharp point because they're hard to model. They create really aggressive surfacing and they limit your options. Remember, a Rhino surface is always a rectangle, and having a point like this is asking for a five-sided surface, which doesn't exist in Rhino. All that to say, I'm not going to give it a hard point. But I'm going to give it a rather hard point. It will mathematically not be pointed, but for all practical intents and purposes, it will be pointed. It's the mathematical point that causes real problems. And I'm going to just do an extend curve here. And I'll just enter a length of 10 because I want to use that. Nope. Okay, that's not going to work the way I want it to. So extend curve by arc to point. Type natural. I'm not sure why it's giving me such a challenge here, except for there must be not really. So it has to do with the math of this curve. It's the best I can guesstimate. So I'll rebuild it to a 9, 3. There we go. That's fine. Rebuild it again, because whenever you do a extend curve. It gives you two pieces, the extension and the original. Give this some more points. Take it to 4th degree curvature. And mirror with history. Turn on my points. Turn on a curve graph. Do the point-to-point shift drag shuffle to get a nice rounded corner here. The rest of the curve looks good. Join it, which will break history. And I really don't want a polycurve, so I'm going to rebuild it, which is going to be a very big challenge because maintaining this very hard point is going to be difficult. I'll try it with 55. Drop it down to 45. Fine. Okay, so I've got that. Now, the strategy as to how I'm going to surface this, I've got to create a series of rectangular surfaces to work from. Okay. But before I bother with any of that, I have to make this the proper proportion and scale for the actual lines I'm working with, which are these. Okay, so I need to take a look at how these differ from this. And try to morph them into a more similar pattern. But you're seeing, you can see that's not really giving me what I want. So try resolving this with just one side. So this is where I'm going to start to scale from. First effort. Oops. It'll be pretty much impossible to match it exactly. Because this is a byproduct of a bunch of flows, right? But it does give me a good relative arc here, which is what I was looking for. And you can see that does vary from what we had in the drawing. So that's going to be the curve I'm going to use. I'm going to copy, paste, and put these on the same layer. Turn that off. In order to sweep this, I want to think ahead of how I can get it to work, get it to do what I want it to do. And the way to do that is to think of this as two surfaces, one above and one below. Do a perpendicular to the curve line. Mirror it over. An offset curve. I don't want the ripples from this modeling that I do to get too far down the side, so that's fine. I am more comfortable with them extending this direction. So going to draw a bisecting angle curve. Don't use it all that often, having a hard time finding it. Right here. Bisector, where are you? Right here. Start of bisector, intersect. First angle, second angle. There we go. So I'm going to mirror that over. Put a straight line roughly halfway between these two to kind of average out what's happening. And do a blend curve. And work with these handles to get something that feels like it's kind of a happy medium of those two parent curves, which I can now delete. Mirror. Join. Rebuild. 15 should do it. Now it's coming undone a little bit. 25. Fine. Actually, I'm going to want that extension, so instead I'm going to split it. Shouldn't say I'm going to want it. I might want it. This is too hard down at the bottom. I could split this out and do some work that way, but I can probably also resolve this by simply rebuilding it lower. Yeah. And we will hope that I don't need the extensions. So that's it. That is the basic surface tools that I'm going to need to sculpt what I want to sculpt. Bring back my official surface, copy it, paste it, put it on its own layer. Something that's easy to see. Select these curves and project them to surface without deleting the input objects. Like so. So what I need to decide now is what the intention actually is here. I have a rolled surface that stays high. And then I have an indentation. Starts high, goes low. Okay? Starts high, goes low. So the question becomes, what is low? I'm going to draw a straight line projected to the front C-plane. I want this line to start high and drop low. One of the easier ways to do this, I'll just do simple control point editing. I was going to get fancy, but there's no reason to. I'll do a 5-3. Turn on the points. Grab this center point and pull down. Want a reference as to how deep I'm going into the surface when I do this? That's probably about right. Take these 2 points. I'm going to non-uniform scale them, so I get a symmetrical tightening around that center point. Oops. Again, this time selecting the proper points. Scale them universally around this point. Except for now I don't want control points, I want edit points. Okay. Rebuild this curve to give me some more math to work with. See, I'm going to have to get fairly high point counts to maintain that dip that I've created. That's good. Well, that's fine, except for now I need to know how it actually meshes into the surface. And for that I am going to need to extend my original curves out a little bit. Explode it so I can mirror it to the other side as well. Oh, interesting. It's a single curve object that I did not expect. So split this. That was very dangerous because if it moved my math of points, no, it all looks the same. Okay. I could have had trouble if I tried to reproject that curve for modeling later. Project these two outside curves. And then project those two outside curves again to the front C-plane. That's important because this curve needs to match the flow in the front view of what's happening up here. Edit tool match. Do not want position. I want tangency at the very least and possibly curvature. I'll go with curvature. Same thing at this side. Turn on my curve graph. See these hard points? That's because this is third degree math. If I want a truly smooth curve, I'm going to have to go to fourth degree. And that's going to require me to rematch the ends. Because rebuilding the curve what's obvious right now is that this curve is not symmetrical. Oh, it can't be symmetrical. That's true, because the curvatures coming in and out are not. Remember, this surface undulates. Okay, then I'm fine with that. And I'm going to sweeten this just a little bit. Remember that curvature, tangency, extends 3 points. As long as I leave 3 points at the end untouched, I'm free to play with that. And I think that's a pretty good representation of what I hope to work with. So, this is the front view. This is the top view. This curve is sitting right on the surface. I can't use that curve. I need the curve that does the three-dimensional action that I need it to do. Just curious what I have over here, because I would like to use that layer. So curve from two views. The flat front view of what I'm trying to achieve. The flat top view of what I'm trying to achieve. And this is the curve I'm going to use. And it will replace this curve. I need a curve running straight down from the end of this. Easiest way to get that point of reference, several ways to do it. I'm just going to do section. Right up the middle. That'll give me a point there. Straight line. No longer projecting it, so it stays right where I want it. No grid snap to fight, please. Straight down. Now I need a cross section of this surface through the center. Through here. Same thing, section command. Lovely. I can only use that section from here to here and from here to here. So I'm going to split it out at the boundaries of my new surfacing area. I'm going to do a blend curve. Going into right C-plane because it makes more sense from the direction I'm looking to control these curves. I don't want anything as aggressive as that. That grid snap-on, which is pretty terminal for and if I look at my drawing, this feels like a very nicely rounded sort of shape coming up and in. So I want to convey that as much as I can. And to do that, I'm going to back off the high power points at the base and use the extensions to create my curvature. So there's my cross section for this side. For the other side, it's very flat feeling, and then it rounds. So blend curve from the same starting curve to here. But now I'm going to want this to drop quite a ways down. And to lay well back. I'm going to look at that because actually an extend by arc to point might work just as well. No. using arc to end snap. Take a look at how that compares. I think that's nice. I don't need this to tuck in a smooth way with the rest of what's going on down below. This can actually come to a hard edge. So there's that. Explode these because they're currently one, and I need my two sections. So that is my kit for sweeping. I want to pause this for a minute and talk about why. This is actually a good instruction moment. Okay, I'm clicking along and I'm doing what I'm doing. And it's all coming together nicely, I think. I'm getting what I want. But the question as to why I'm approaching it the way I'm approaching it is a useful question to answer right here. I laid this shape out from my original design so that I would have a square-shaped surface to work with. And that is a square. It's got a wave, but it's a square, a rectangle, sorry, four-sided. And it's actually two. It can be split, coming in from the back, coming in from the front. But both of these are four-sided rectangular surfaces. So I drew out the detail in a way that I knew could be surfaced as a detailed portion of this surface. Okay? I wanted to make sure that the line went as far as this went before it faded out. So, you know, I carefully drew this, and then I carefully projected it up onto the surface. So here we have the rectangle, but obviously I want to sculpt down inside. All right, and this surface is not going to be useful. I could possibly control point edit this to get what I want, but it would be very tedious. I'm going to go ahead and join these curves together. I'm going to trim this out. So we can look down inside. Okay? So I want this to create this folded effect down inside of there. So this is the kitchen where I'm going to be doing all of the cooking, as it were, right down in here. This is a construction curve. The thing I wanted to point out is, why did I do curve from two views? This is an excellent example of why you use curve from two views. I frequently say that you can't draw three-dimensionally in Rhino. Everything you draw in Rhino is flat, and then you use curves from objects tools primarily to have Rhino create the three-dimensional curves. Because drawing three-dimensional curves is very, very challenging, almost impossible to do, and virtually impossible to do with any kind of predictability or to specification. For example, if I tried to create this curve using another method, I'll hide it for now. Actually, I will hide it and its cross sections. If I do a blend curve between these two, because that's the only way I'm going to get a curve in between those predictably. I get that. Well, that's not going to do anything as far as creating that flow down in crease sort of effect. Certainly isn't going to follow the directionality of this that's part of my design, right? Well, I can play with it. Sure I can. I can rebuild this curve. Give it a bunch of points so that it's editable. Don't want to do 15. It'll take too long. Let's say 11. And I can turn on the control points. And then I can grab this, go to a vertical C-plane, and I can pull it down. And then I can grab this and both sides symmetrically and pull it down. And then I can pull this down some more. All right. But it's still not at all following this. So now I have to take this point and move it straight forward, because if I move it side to side at all, I've changed the up and down shape of it. So this is how you do control point editing. You choose each direction, one direction at a time, and you use your shift key, so you're only going in one axis direction at a time, and that's still not matching at all. Okay, so then if I wanted to, I could then either rebuild this or insert not. All right, I'm not going to keep going. What becomes obvious is it's not precise. It's very hard for me to control. It's very hard for me to see what it is I'm making. It's because I'm trying to draw in 3D. Don't try to draw in 3D. Learn how to draw in 3D. Everybody should know how. This is how. But don't do it. Resist the urge unless you absolutely have to. Because it's much more intelligent to use curve from two views. Curve from two views. I decide what I want this to look like from the front. Okay, I've done the blend curve. I projected it flat to the C-plane in the front view. And then I control point edited this front view of what I want. It's very clean. It's very easy for me to see. I know it's flowing between these curves, so I know it'll be smooth. Complete control. I drew that front view to absolute specification of what I wanted the front view of this curve to look like. And I already have the top view of what this curve is supposed to look like. I took it from my drawing. So having those two curves, then Rhino has a command that makes generating 3D curves very easy. If I have two flat views, take my front, take my top, and there's the curve. All right? So it's just smart. It gives me, it will be, this curve is exactly the top view. It is exactly the front view. There's no guesswork involved. I got exactly what I wanted. The only question is, what do I want? I have to know what I want. When I drew this front view, I had to have in mind what I wanted that curvature to be from the front. And of course, when I designed it, I had to know what I wanted this to be from the top. Now, so I hope that helps explain why I went to the trouble to do curve from two views. It was simply the fastest and most controlled way to get where I'm going. Now, before I do the rest of this surfacing, this hump doesn't make me happy. It might be what I need to have this feeling, but I don't, it seems really abrupt to me. I'm going to try that blend curve again to see if I can get something I like better. I'm going to pull that way down, because it's the real leaning in on that I don't like. Yeah, I think I like that better. Okay, so there are my sections. There are my rails. I have 3 rails. Well, explode this. I have 3 rails. I have 1, 2, 3, 4 sections. That's not going to work. Only way I could make that work is to join these two together. And I would have 1, 2, 3 sections. But the problem with that is it won't obey this crisp curve. These two portions, in order to stay cleanly delineated, have to be separate surfaces. So since I can't join these together, I need to split these. Splitting the curves is easy enough. I just do that. Now I have rail, rail, section, section, and section. And the same thing above here. Great. If I were just doing curves, my surface from curves, that would work fine. Surface from curve network, rail, rail, section, 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 we're done. Rail, 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 section, 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 we're done. Okay? Perfect. I have it. It even fits nicely in the hole. The problem is it won't be smooth to these surfaces. There will be a seam. You can see it there. If I make them all the same color and I E-map them, the seam will be obvious. Okay? That's a problem. And that's why we won't surface it that way. The beauty of surface from curve network is that it allows you to take tangency from the surrounding geometry to keep things smooth. Our only challenge here is that I only have one surface edge here and I need 2. And Rhino has a very easy solution for that. Analyze, edge tools, split edge. I can select this edge and I can split it at that point using end snap. Same thing here. Having done that, now I can do the same surface sweep using the same rails, but now I'm going to use only one curve rail. All the other rails are going to be edge rails. So I don't want the curve. I want the edge, surface edge, because this surface command will read the tangency flow information from that surface edge. I want this curve rail. It's the only option I have. And then for my sections, once again, wherever I can use an edge, I'll use an edge. So not there, there, curve, and there. This creates a very similar surface. But without the obvious seams. The seams are still there, subtly, but much less apparent. I've decided I would like to push a little harder from the sides because I want this to fade in a little more. So do the command again. Edge, curve, edge, curve, and edge. This time for A and C, I'm going to take it from tangency to curvature. And that will push a little harder from these edges. Now that might create, see the bulb that I'm getting here? That's the risk of doing that. I'm afraid that's not going to be nice. But being able to control that and monitor it is the beauty of that surfacing command. So it does come in really smooth, but then it kind of pillows. And I don't love the pillowing. So I think the best surface here is the first one I did, using straight tangency. So edge, curve, edges here wherever possible. And we're, oh, except for I didn't change the setting. Rail, section, section, section. Okay, all tangency. So now we're going to do the other side. I'm going to use edge once again. Now I could use the edge here, but if I use this edge, it'll try and pull tangency off that green surface, which will just make things crazy. I don't want that. I want just the curve. I want it to ignore this surface as far as flow. And then edge, curve, edge. That allows this to fade out very nicely here, and yet keep a nice tight corner. I'll take a look at that. And see if I like it. And I actually think that's pretty good. But I would like this to be even flatter, more flat. So, how am I going to do that? Well, I could play with the control points, but I might get something less predictable. So what I'm going to do is I'm going to draw a curve. I'll actually let this do it for me. Curve, extend curve by line. That's the direction it's going into right now. Exploded that back out so the extension is separate. I would like it to be flatter. So I'm going to rotate this curve to create more of a flat trajectory coming in. And then do a blend curve here again. And that's going to give me that straighter cross section, which I think is I'm going to like better. Let's find out. So, surface and curve network, edge, curve, because I don't want to take tangency off the green, edge, the flatter curve, edge. Join these together. And I like that better. I like that this rises up the way that it does. And the rest stays pretty flat. I think that's nice. That's suitable. That's what I'm looking for. So, to finalize that, I would like to see how it looks float up. Join those together. Do the rotation with copy, 180. Mirror that across. Join everybody together. And flow. Transform flow along curve. Flat top, flat front. Yeah. That's nice. Bring in the stones. And that's loyal to what I wanted to do. So I'm happy with it. I'll go ahead and undo that flow. Because it was just a look and see thing. I'll actually go ahead and undo the rotation as well. This is a scrap from the initial offset surface I did a while back. So there, we have this. Now the thing I have to think about now is how that impacts hollowing. Because I have two new surfaces here that weren't there before that sink quite a ways into the part. So I'm going to extract some copies of this. And I'm going to offset them 1 millimeter. Okay, I did not expect a success. This does not surprise me at all. It is a challenge for me, though. Because I would like that to be less of a challenge. So, I'm going to join these together. Going to pull a cross section from the middle. Just like that. And I'll grab the edges of this surface, the border, like so. And actually, I would like this. So I'm just recreating that sweep kit. But where it comes through here, I'm going to let these blend. And even bigger than that. And I'll do a blend curve for that. Join this together. I'm going to try not using this rail at all, seeing what I get, see what I get. Sometimes less is more. Surface and curve network. All curves this time because that's all I have. I think that does a respectable job without even including this curve. Now, we can see that that is not really faithful to the original surface, but it's faithful enough, and more significantly, as one single surface like that, it will let me offset it for the hollowing. -1. And that is the surface I need. So, somewhere here in the mix, I have my here it is. That's my flat cutter. And you can see how that is cutting in. That's how much it bites in. And that's enough that I need to accommodate that. It's not a very attractive connection. I'm going to take both of these and get an intersection. That is the intersection between those two surfaces. Really not lovely. Not only isn't it lovely, it's not even complete. Right? Really not nice. So I'll just go ahead and take a bit of that off. Three-dimensional curve, how do you trim it? You trim it with a sphere. Circles don't work anymore. You're not flat. But you can draw a sphere and trim with that. Blend curves. Get something reasonable. Join all of this together. And then rebuild it to something reasonable. It's going to be something unreasonable right now, like 2030. Let's try 36. Usually 36 for a closed circular shape will work. That's fine. That's close enough. Because what I'm going to do with it is I'm going to create a pipe. And I think that may not be enough. Let's take a look. That's how it interacts there. What did I do? Here. That might work. I'm going to go a little bit more. I'm trying to find a way to create a blending surface between this new divot that drops into my hollow cutter and the cutter itself. 1 millimeter, I would like it to be as big as I can get away with. I can do better than 1 millimeter. 2 might be pushing it. Let's try. Some strange corners going on, but that's actually fine. That'll work. Okay. So I'm going to bring back my surface that I made. First I'm going to copy, paste, group, and put this into storage. I'm going to grab this and I'm going to use it to trim off the edges of this surface to the inside edge. Okay, that's a problem right there. Stop. Back up. I can't have a kink in that pipe. So 2 millimeters was too big. A little bit of a kink. Okay, problem is how sharp that corner is. Just going to use Shift key and push it straight back. That's going to take it off the surface. It's going to mess with things a little bit, but it should be within tolerance. There. That's fine. And once again, use this to trim off to the edge of that surface, the inside edge of that pipe. Pipes are great universal cutters. Pick up the excess stray bits of surface and bring in here. I'm going to trim away any of that on the inside. Like so. I need to, this thing can throw away. I need to duplicate these for the other side, which is done by a rotate because we have the weave going on. Copy, yes, 180. I have to make sure I didn't throw away the wrong thing. I threw away the wrong thing. I want to throw away that surface. I need the red one. And then using this cutter over here, trim away that to the edge. Now I can throw away the cutter and that surface. And now I can blend. Between this edge okay, we have a bit of a problem. That will never work. So I need to merge edges. Analyze edge tools. Merge edge. And I'll keep doing this until this is fully, that basically just made, there were no multiple little scattered edges anymore. That'll only work if this is not a poly surface. If it's a poly surface, those edges can't be merged, but it's a single surface. The reason we had all the little snippets is because it's a terribly sophisticated surface. It has 162 points in one direction and 43 in the other. And you were cutting it with a pipe that didn't quite match it. So there were some edges that were questionable, but that was able to fix that without any problem. So now, blend surface. You want to pick where that handle is, where that handle goes. That's not a good place. That's pretty good. You don't want a tight corner. That's good. And this will allow you to see how that blend is being handled. Adjust these until you get a surface that you like, and hit OK. And I will rotate that around with a copy. And that should do. Join it all up. Check how we look with the Lee map action. Okay, that's a little too abrupt. I adjusted that blend surface too much. It was because I kept seeing this curve and it was confusing me. I'll go ahead and delete that curve for the pipe. And this time I'm going to accept the default. Take it to tangency. Okay. And whatever that is will be fine. Once again, this is an inside surface, so perfection isn't necessary. But it should always be nice. There's no reason to do ugly surfacing if you have a choice. There, nice and smooth. And then cap the back of this. So I have that. Flow that. Take our newly sculpted surface, rotate it around with history to create the other side. And mirror this across. Now, with these, it becomes a bit of a challenge because we do want to Boolean them together now to make them a solid. And somewhere along the way, I have lost my sidewall here. Oh, it's there. Okay, good. I'm confused where it's gone here. Rotate. There. Join this together. Put these caps on a different layer for a minute. In order to put a cap on the back of this, I'm going to have to close up these sides. Two ways of going about this. One way is to cap the ends and then close the back. The other way is to close the back and then cap the ends. I'll do that. So I'm going to do a duplicate border. I'm going to explode this and remove these end sections. So all I'm left with are two flat curves. I'm going to join. They shouldn't join. They should be just a single curve, which they are. Good news. And I'm just going to draw a straight line to close this in. Apologize for that being hard to see. This green doesn't show up very well here in curves, but there we go. Surface, planar surface. Throw away the curves now. So I have the back. Go ahead and rotate that around. Join this together. Cap the ends. Solid cap planar holes. Join this. Cap planar holes. That's it. Copy, paste, group, put in storage before I Boolean. Solid union. I got a solid difference, so try solid difference. Got solid intersection. Try solid intersection. Got difference again. So Rhino's going to fight me on getting this Boolean to work. That's very annoying. Like 10 shades of annoying. Rhino doesn't like to Boolean. It's a little commonly known thing. So I'm going to try and just be able to move this down. Because the problem it's having is that both of these are at the same elevation. That's what it doesn't like. And cap this. Oh, wait a minute. That may not have been the problem at all. There's not a cap here. Okay, duplicate border. I've got one curve here. Planar surface. And it says no because it's not closed or planar. And that's the problem right there. Fine, patch. At this point I'm not in the mood, so patch. That'll work for what we're doing. Same thing over here, patch. Duplicate border and a patch. That shouldn't be the case, by the way, since those were done with straight plane cutting planes and all that careful work I did to make sure that I wouldn't have trouble. Still had trouble. Fine. Solid union. Before I do, make a copy for storage. Solid union. I need to make sure I have that flat surface on both sides. I do. Okay, so now I'm going to extract this surface. missing the inside over here. There we go. Join it all together. Remove the cap on the back here. And hopefully we can cap the whole thing. There we go. That's now finished, sculpted and finished flat. So I'm going to flow that up. So got that in place. We've got this in place. Copy, paste, group, storage. Boolean difference to hollow it. That's the completed bangle, including shelling. Okay. Now I'm looking at this and I'm realizing there's something I don't like. This hard corner. Getting rid of that hard corner is as easy as filleting these before you Boolean them together. So, because these inside corners are going to be hard to fillet. Fillet won't navigate them well. So solid, fillet edge. I know it's going to be hollowed with 1 millimeter. So the radius of this can't be 1 millimeter. Can be 0.7 probably. And now when I Boolean union those, there will be, now I can check, by the way, and see. See, there's still room with the hollowing. So copy, paste, group, storage, Boolean union. Stop. Before I do that, there's always a level of more of detail, folks. I'm going to redo that fillet edge. I'm going to want these fillets to match the ones on the end caps. To do that, there's an option. Once I select my edges and I hit enter, there's a choices here to change different sizes and handle lengths and whatnot. But one I want is rail type. Instead of rolling ball, which is a more organic treatment, I want distance from edge. It looks about the same, but it makes it a mathematically determined fillet from the edge of the piece. And having done that, in storage again. I can now Boolean union these together. Take off the end caps. Actually, before I take off the end caps, it's a little different procedure because I have complicated things by choosing to put that fillet. Same as I did for the other. I will duplicate the border, explode the border, take off the end section here. So all I have are the outlines. Join them in case they're polycurves. They shouldn't be. Good. Straight line. End, 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 end. Fit's really important here. So that object snap kept saying mid, and it looked right, but I didn't want to take a chance. Join these together. Closed curve. Surface tools. Planar surface. Delete the curve. Join. Cap. Hopefully. Wouldn't cap either one. Fine, patch. Borders. Oh, gotta do one at a time. I can just mirror that over. Join these up. There. And now I can fill at the edge. Extract the surfaces. Mirror it over. Get rid of that one, so there's no confusion. And bring back the center section. Remove the surfaces off the caps of this. Join them up. I don't like having multiple back sheets here, so even though it's a solid right now, I'm going to remove these. Replace them with a single cap. Flow that along curve. Copy, paste, group, store. Difference. As before, but now with a more comfortable edge. Which is important. Okay. Last thing I want to do with this is change the prong diameter. Unfortunately, I discovered that I didn't like the prong diameter for my settings. Somewhere in here, I have my stone setting. right there. See, when I group things together, even though it becomes a spider's nest, I can find them. I've decided that the prong is too shallow. Fortunately, each one of these is separate, so all I have to do is scale them up and reflow. Transform, scale, 2D, center snap, 2 divided by 1.5, taking it to 2 millimeters. It's probably too much. 1.8 divided by 1.5. That's better. Same. Same. Okay. Now all of these are now biting too much into the stone. I want these to just barely kiss into the stone. So okay. Challenge is I am completely out of layers. I'll just move this out of the way. And for now, I'll put it over on the surfacing 4 layer. Having done that, what I'm realizing, of course, is that I'll have to move everything back. And I actually wanted to do that. That's actually one of the positives of my decision to do this. Is I want to, this gap here, I can minimize that even more, and I like the idea of doing that. Grid snap on. I don't want there to be a gap between this prong and the bottom of the mounting. But the challenge I face in doing so is that, no, the stone's fine. I would do well to set the stone in a different color if I had a different color to use. Oh, sure. I can go with green. Group these together. As long as the stone doesn't run into the wire, I'm fine. Yeah, that pocket right there is too much. Okay. But now that I see that, this will need come around. That curve can be deleted. It's been moved, so it's no longer accurate. I'm going to record history on this, so if I keep adjusting, I don't have to keep doing it twice. Okay. It's going to require some 3D examination. I think I can move this back a little bit. They're a little too tight together right now. But I think there's enough relief. Yeah, that works. Okay. Now, if you can remember all of the things that I had to do to make this work. First time. Group everybody. Flow along curve. Flat. Rigid, yes. Front. There we go. So that's in position. Ungroup. Group that together for a minute. Extrude straight. Check direction. Flip it so I can Boolean. Ungroup. Fillet edge. I believe it was 0.75 that we did last time, so. Apparently not. All right. That's 1 point. Oh, so 0.7 would be the most I could do. Okay. Like so. Solid union. That wasn't very successful. Solid difference. That didn't work. I recall we had a difficult time with this last time. And the solution I came up with was to create a cutting tool that went right through here. If I still have the flowed version of this, in storage, I might be able to just borrow that surface that I'd cut right here. Yeah. That is not going to really help me, I don't think, unfortunately. I would love it if it would. Oh, maybe. Okay. I spoke too soon. Extend. Check direction. I want to trim off the back edge of that center motif. Check and see if they'll Boolean. I'll just copy them to clipboard in case they do. Solid union. Union failed. Okay, if I remember right, I also had to move these down just slightly. 0.02, I think is what I did. There we go. Paste in the ones I had in storage there, group them, and store them away. So, we've got that. Extrude straight, check direction, solid difference. Wrong way. Okay, fill at the bottom of these. .7's too much. I'm getting distortion there, so 0.6. It's better. Copy paste group store. Union. And there it is. Completed setting. Mirror it over. Compare it to the old ones. I like that better, yeah. So there it is. Copy paste group store. Solid union. put that back in storage. These are now obsolete. I'll store them, but I could just as easily throw them out. And that is the finished cuff. And based on the original design. That's it. Thanks for watching.